What?
He wants to know
Like,
how we know how old we are.
How old you are.
You keep time, bro.
Yeah, but how would we do
You don't need the globe model to keep time.
It's based on the globe model, right?
It's actually based on, empirical observation, the movement of the sun, which supports the flat Earth model, not the globe Earth model. But okay.
Oh, we went there.
Yeah, but how many times? Let's just use the flat Earth for a minute. How many times would the sun have to go around above the flat Earth to determine 1 year?
The same amount of times. The effect is the same.
Amount of time.
The explanation is what differs, but the effect, the empirical observations actually support flat Earth more.
So
because
how so? How
does it
so?
speed up?
Because we see the sun move.
How does it speed up?
Which is what the flat Earth conception says.
If it's lower or higher in your horizon, wouldn't it mean that the circle is going to be a different circumference throughout the year? So is the sun changing speed, changing velocity?
Yeah, I imagine it wouldn't be changing velocity; it would be a constant speed. And in terms of the change, in terms of the proposed change in angular size, maybe it's explained by a simultaneous atmospheric lensing.
Come on. We know where the sun is.
Wouldn't that be coincidental?
Stop it.
Kind of like, hold on, let me finish.
Stop for a second.
You asked me a question I'm answering in completion.
You're not answering it. Let me just finish my question real quick. Go on.
It's coincidental as saying that the moon is, the sun is 400 times the distance than the moon is from the Earth, and yet 400 times the size as well.
With trigonometry. We can change that with, yes, it is coincidental actually. It's not exactly the same size.
It's crazily coincidental.
It's not exactly. It's not even close to exact.
It looks exactly the same size.
No, it's 3% off.
Obviously, you've never seen.
But hey, you're diverting. Wait, he's diverting.
This is work, bro.
Tactic. Hold on. You said same velocity. I'm saying we know the sun is a different angle in the sky throughout the year. So it has to. If you're going to always have a 24-hour period, we know it has to have a different velocity. Same angular velocity, different velocity, right? So how is that possible? What's speeding it up and slowing it down so that it continues to have the same angular velocity throughout the year, even though its position is changing?
It could be that it's, speeding up during in terms of...
Well, it has to be, right?
Right? Not necessarily has to be. It could be that...
We all know a larger circle,
a little bit as well.
Period. God, you have to stop when you finish talking.
Bro, you keep on trying to interrupt my answers, and then
I'm giving you the answer.
Ask a question, Zanik, and then you talk through the answer.
Larger diameter, larger circumference, and it's the same period, it has to go faster. Do you know how it's possible to not do that?
What height is changing, Zanik?
What?
What if the altitude, the height of this thing is changing?
Okay, so what's changing the altitude?
Would then not, with maintaining the same velocity, would that not change how it looks in the sky? The angular speed?
No, because we see it straight over the head.
No, it actually would.
We see it straight over the head in some parts, and then it doesn't. It's not over the head throughout the year in those same spots. So we know it's not changing.
You're referring to the analemma. You're saying that there's a change in the angular speed.
I'm not referring to the analemma. I'm referring to when it's straight over someone's head on this Earth at some point in the year, and it doesn't stay over your head. That means it's moving. You know that.
It's moving.
Not moving as in position, as in the circumference must be larger because it is moved from straight above your head. If it was just going up and down in altitude, it wouldn't move throughout the year. It's moving left or right.
Yeah, we know that.
Okay, so you got to see that it is changing velocity because it's describing a different size circle throughout the year.
Maybe.
Right? So
maybe
not maybe. We see that. You said empirical. I'm giving you the empirical evidence. What we see a sun that's at a different angle throughout the year. And if it's above your head, it's not above your head the next day directly. So we know it's moving. So we know that circle's got to be changing. That means the velocity has to change because the period.
No, you're assuming stuff. Again,
the angular velocity is the same.
It's possible that the height is changing and the light is refracting such that it's still above your head.
No, light doesn't refract when it's going straight down.
How do you know it's not? How do you know it's going straight down? Did you go up to the sun to know it's right there?
Looking at it.
Because the sun is 9 degrees above your head.
Through
this bending, 9 degrees above your head, obviously.
It has to be
through light. You only see it because light is reflecting into your eye, so that light could be bending.
No, you're so confused. Always, when the sun approaches directly above your head and then gets above your head and then leaves, at some point it would have to be above your head. You agree, right?
Hold on.
Where would that point be?
Light that enters your eye,
right above your head.
Enters in straight
you're not
lines.
understanding really at all how light refracts. So that's
no, you're assuming that just because we see something somewhere that it
why would light refract? Why would light refract?
You're basically saying refraction doesn't exist now.
No, just why would it refract for a sun that's above you? What would happen? How would it do that?
Who knows? We don't know what the medium that this light is in.
We understand.
No, so you're just assuming stuff again.
We have satellites, or balloons as you call them, that measure the composition of the atmosphere from the lower troposphere all the way up to the stratosphere in the space.
No, they don't.
Yes, we do.
No, they don't. They don't measure
we know there's a billion
where the sun is.
Hold on. We know there's a billionth of the atmosphere only at 150,000 feet. A billion.
You have no clue what the atmosphere of these
we measure it.
The medium of the objects are.
The composition is pretty constant up to about 50 miles. So what do you keep on saying we don't?
You
Why
have
do you say
no
you don't know about?
Medium
the models on it.
These
tell us you think you know
celestial objects are, let alone what the objects are themselves. You have no clue.
What objects?
What celestial objects?
The satellites? The moon?
Lord have mercy. What do you think we're talking about right now?
Yeah, Lord have mercy on your soul.
He's claiming we don't know what the sun is again.
There you go. At least someone
can keep up. We don't know what the sun
is.
Oh, it's a black object. And it absorbs all the radiation. Is that what you're going to say? So we don't know what it is.
That's not what I was going to say at all.
I don't know. You tell me. You said we don't know.
Anyways, this is a nice little.
We do. We know You can just take a telescope. You can buy from You can get it at Goodwill for $20, and you can study the moon night after night. Map it out if you'd like through all the phases, the complete surface, like they did hundreds of years ago, and you can determine that it is spherical and even close to what is probably.
No, you can never determine definitively that it's spherical unless you go up there.
Oh, absolutely.
No, you can't.
Yes, you can.
Yes, you can. All you gotta do is look at the shadows. Look at the shadows that it creates.
The shadows will determine.
We only have one angle. You need more than one angle to appreciate depth.
We have one angle. We have many angles.
The shadows that are cast on the moon.
One angle, the angle from Earth.
Only possible on a spherical object.
Crazy. No, it moves
until you get off Earth and you have, another angle to look at it to appreciate the depth to see that's actually a sphere.
Yeah,
then you can talk about. We always have a 2D image.
You can take a picture
Changing 2D image, yes, a 2D image that has the appearance of tour and shadows. Yes.
Is it a full moon tonight? Yes, it is. Why don't you look at it where you're at? Take a picture. I'll take a picture. And we can compare it. If you get very accurate pictures, there's two different angles, and you will be able to measure the curvature just with that. It doesn't take a lot to do this percentage. You're being a troll.
It's a full moon, and I'm not surprised that you didn't turn into a wolf. You know why? Because you're sheep.
You're a complete utter moron, or you are just a troll. Which are you?
Well, we were talking about, I think what we were talking about is the model, remember? The model, Zanik. And B-Ball for Life was saying that the model, another model, but it doesn't represent entirely reality, what we're trying to do.
Well, what parts don't represent reality, Kibo?
Not just her percent, we've just been through it.
Do you guys mind if I talk about something else?
Because he's wrong. No, because he's wrong.
Yeah, what's on the table percent?
Alright, so, the Antarctic Treaty. They say it's like, when flat earthers bring it up, they say this is, it's the first kind of agreement between all of the countries of the world, or maybe even the only one. Mm-hmm. And I just want to, is that true? Has anyone kind of, have we looked and did our due diligence to confirm that? Because I've come across, these other conventions and treaties or what have you that have seemingly way more members, way more member states, and were enacted before, well, at least one that I've looked into was enacted way before the Antarctic Treaty.
What you're claiming now? Again, you're gonna go with the claim that we can't go to Antarctica now?
Oh, it was put into
what
place.
What the fuck are you talking about?
No.
Making it a pro.
I'm calling you.
Argument right now.
The Antarctic Treaty was put into place so that everybody in the world will leave the fuck alone Antarctica.
Yep.
Nobody's allowed to dig it up. Nobody's allowed to go there and rape it and fucking pillage it and turn it into a swampland. That's all it is, right? And all the fucking, like, reefs and all the fucking sea creatures and shit around it, they're all protected as well.
There's other places on the earth that are even harder to go to.
Yeah, because they're protected by, like, fucking really evil shit. And you go to them islands and you just end up being eaten alive. So, and that's just by the people. So there's no point in going to them islands because you just end up dead instantly. And it's not like, yo, yeah, I might die. No, you're just going to die. It's as simple as that. You know, you're dead instantly.
It's harder to go to Mount Everest than it is to go to
because the altitude, you probably die of suffocation before you got to the top of that.
What is this treaty percent?
Okay, so the Antarctic Treaty has 54 parties, right, that signed on or whatever. I came across the Warsaw Convention, which is like, you know, it governs basically liability in terms of carriage by air, like when you're traveling by plane internationally. And there's 152 parties, and it came into force in 1933.
The 152 parties, though, they're only what they call it research. They're going to like core drill, take out core drill samples, you know, and look for air changing patterns.
What are you talking about, man? This has nothing to do with Antarctica, man. I'm talking about a completely different convention.
I've changed the fucking subject already. Jeez,
yeah, I'm showing precedent, something that came before that has more parties.
Nothing.
Yeah, and so what?
Yeah, but what
mean, so what? I'm saying,
what's the point?
He just asked. His
Lord
point,
have mercy.
Goddamn, he asked if that was the first one, or if there were others.
He haven't been the first one. He haven't been the first one. We have had a lot of treaties before that treaty.
With that many nations and so forth. That was his question.
Well, yes,
so we don't bomb the fuck out of each other and kill each other during war and all that. Yeah, they're them treaties we're put into place for that reason. So we don't rape and pillage each other.
Way before that.
Yeah, that we don't.
Not the first treaty.
After that, we also had the Moon Treaty. That happened.
Well, you know, you just can't walk in somebody else's country and start digging it up and say, yeah, that's my fucking coal. It's like, no, it's not your coal. Fuck off and get your own coal. That's why the treaties were put into place.
This treaty is all about liability for international carriage of persons, luggage, or goods, and it was first signed in 1929. And I'm sure he's reading the same page I am. As of 2015, it's been ratified by 152 states.
I'm not reading the same page, but yeah, same info.
And still the question is, so what?
Apparently, you guys have, like, listening disabilities or something like that. I was making, like, a pro-globe Earth argument, saying that maybe us flat earthers haven't done our due diligence in terms of, you know, checking out the claim that a lot of flat earthers make, which is that let me finish, bro. Come on,
let him talk.
The claim that a lot of flat earthers make, saying that the Antarctic Treaty was the first and only treaty that's agreed upon by all the countries in the world.
Oh
well, and actually stuck to
Mike, but yeah, who gives a shit? So they're wrong. Well, we're used to that. Flat earthers are wrong.
It's a bit of a bogus statement, really, because it's like all treaties are fucking made to be broken, just like all legislation's put into place, just to piss people off and to be broken.
Oh,
you know. So you know, it's like. It doesn't really matter what treaty you put into place. Some cunt's going to go there in the middle of the fucking night and dig it up whether you like it or not. You know what I mean?
I'm not even mad that you took what I said and just, like, absolutely shit on it. Because you did it in, like, and I don't give a fuck manner. It's a funny fuck.
I'm surprised you didn't pick a more famous one, like the Treaty of Versailles, signed after the war in 1919. That's quite.
How many parties?
Oh, God knows. Quite a few.
This one, the Warsaw Convention, stuck out at me because it has almost triple the amount of, parties that entered into it.
Versailles, there have been all the countries that have been involved in the First World War.
Yeah, which was quite.
So like 7.
No.
7. Joking.
So your history's a bit poor then.
Might be early, but we aren't daft. Just because people sound different and have different accents doesn't mean they're brain dead.
Where'd that come from? Are you just brain farting?
Well, yeah, sort of.
No, that's fair.
You call it an episode, couldn't you, really? I don't know.
Fair enough.
We all have episodes, don't we?
Yeah, from time to time.
Yeah. There's a time and a place, lad, aye.
Aye. Blimey, what a lot of treaties.
This Warsaw Convention and like the Montreal Convention that like replaced it, it's interesting stuff. It basically like talks about how at the detriment of like individuals' rights domestically, they have like this exclusivity kind of agreement where for like, you know, all of the different countries to be on the same page.
Yeah,
they play by the same rules. So basically you have like, you know, if it says anything in the convention that would go against your domestic, you know, freedoms in your own country, your domestic freedoms don't really matter, because in terms of the exclusivity, that the Montreal Convention always takes precedence. It's always the priority.
Oh, that's interesting. The treaty with the biggest number of parties signing up to it, in 1985, the Vienna Convention for the Protection of the Ozone Layer. 197 states.
There you go, guys. We got a new Antarctic treaty.
Well, obviously the ozone layer was a very big problem, and I think, if I remember rightly, we've pretty much taken care of that by not using CFCs anymore. I think there is still a little bit of a hole down south somewhere, but I think it has by and large fixed itself because we stopped putting that shit in the air in the first place.
I call bullshit.
Of course you do.
Show me the ozone layer.
It's just there, look. Show me the ozone layer. That's like saying, seriously? Show me the Van Allen belt.
Did they shoot radio waves like all in every part of the sky and get readbacks in every part of, like, you know, everywhere they shot it all over the earth?
Do you know,
and that's how they know where the hole is.
Wasn't even done with radar.
Mate, can you explain to me ozone without the gravity?
Can you explain to me the ozone? Because so far I haven't seen it existing.
Yes, the escaping of oxygen from the electrons of oxygen that are escaping from the stratosphere.
Did I say explain? I meant demonstrate.
Oh, demonstrate. Okay. So do you want me to send you exactly over the stratosphere to put you in the ozone layer? So what do you want?
I want to know how they see it and found it and measure it.
Very easy. Put an instrument that is measuring oxygen.
That's it. They just measure oxygen.
It. Yes. What is ozone? O3.
Correct.
Chemicals. O3. Oh my God! You don't reach not even those things.
What height though?
With a spectrophotometer.
Or yeah, or with a spectrophotometer, like that. Oh.
How high is the ozone layer?
It's starting from over the stratosphere, I think.
How many miles?
I remember
What portion of the stratosphere?
How many miles up?
922 miles.
22 miles. So we have devices that are 22 miles up measuring oxygen?
No. You can measure it from the ground with a spectrophotometer.
Sure you can.
Yeah, you can. I mean, I know you're just poing, so you know.
No, you actually can't.
Yes.
You might be measuring colors.
No.
And they might assume that this wavelength of color corresponds to this element or this molecule, but you don't know. You're not actually measuring it.
You're so naive, it's just mind-boggling. Go look up how mass spectroscopy or photospectroscopy works, and then get back.
I know how
it
works.
No, you don't. How does it work?
I know how it works, and you can't use it to measure.
How do we know if
something that's 22 miles up?
How do you know if we're looking at oxygen or ozone in the air? If I just look in a room and I wanted to detect ozone or oxygen in the air, how would I do that?
You'd use a mass spectrometer.
How would that work? How would it discern between oxygen and ozone?
Probably the amount of charge.
Oh dear.
Amount of charge. What does that mean?
Amount of charge.
Amount of charge. So higher charge.
Which word do you have problems with?
Well, I'm asking you. You tell me. Higher charge, different element. Is that what you're saying?
Not necessarily.
Well, that's what you just said. I'm just repeating it back to you.
No, I didn't actually. Nice try.
Yes, you have been said something like that.
I said the amount of charge will help you determine between oxygen and ozone.
So amount we have value.
Oxygen and ozone different elements to you, Zanuck?
Of course they are.
Really? They're different elements.
Ozone is made up of different elements than just oxygen.
What's ozone?
O3.
Yeah, so what elements is O3 made of? Other than oxygen. That's what I thought. Sit down.
Are you going to answer his question though, percent?
It's made up of oxygen. Doesn't mean it's oxygen.
What?
Oxygen O2. We talk about oxygen. We talk about O2, right? Would you agree?
No, the element's oxygen.
If we detect oxygen, we're looking at O2.
You tried.
No? Yeah, you sit down. You sit down now.
Bro.
It's an idiot.
If you want the last word, that's fine. I'll give it to you.
No, it's not the last word. It's you being a moron. You don't think we can detect things in the atmosphere using a spectrometer?
No, I don't think you can.
So spectroscopy is not a real thing. What about what
I say you in the class. What's on share?
You can't do mass spectrometry with things 22 miles up in the sky.
Why not?
Because when you do it, you need a sample to which you measure the charge, right, of whatever it is.
I don't know. You tell me. You seem to be the expert
on whatever it is, and you need to have that sample. You're not going to magically get it from 22 miles up in the sky.
Yes, you can. You can measure things from
much
higher, actually.
So I don't know why you keep saying charge. What you're doing is you're measuring the frequency of the radiation. You're looking at the color.
Right.
No, you're confusing a mass spectrometer with.
I'm not talking about mass spectrometer. I'm talking about spectroscopy.
Yeah, you're confusing it with spectroscopy. He said mass spectrometry.
I'm talking about spectroscopy.
No, I said
he said mass spectrometry.
You're not using a mass spectrometer to do that. I said go look up mass spectroscopy and spectroscopy, and then come back.
Why would you mention mass spectroscopy?
Mass spectroscopy.
Run the tape first. I swear to God.
Well, either way, the claim that was made originally, it was very clear that spectroscopy can be used.
No, it wasn't very clear because he literally said mass spectrometry.
He didn't say mass
if you want to untake, that's fine. If you want that, that's cool too.
I said go look it up and see how it works. I didn't say that we're going to use mass spectrometry. Hey, I was very clear. I was very clear. Hey, Presenter, shut the fuck up. I said go look up mass spectroscopy and spectroscopy to see how it works because you know nothing about it. And now you're saying I'm applying mass spectroscopy to looking at things in the atmosphere 22 miles up? No, that's a lie right there. I didn't say that.
You said mass spectrometry.
Yes, I said go look up. I said specifically.
Well, it's not relevant.
Mass spectroscopy or spectroscopy and see how they work. You don't know how they work.
They're two different things, and only one applies to the context of the conversation that we were having. And the one that applies is the one that I was talking about, which is checking the wavelength of light and assuming that it corresponds with specific gases or molecules.
Why do you think you can't do that 22 miles?
Or mass spectroscopy or whatever. The point is,
why do you think you can't do that?
It's a completely different technology. You're measuring the
Why
charge.
do you think you can't do that?
It's right there.
Why do you think you can't do that?
You can, but you don't know it because you're still assuming.
What makes you say that? What makes you think we don't know that?
To gases or to elements.
What makes you think that it hasn't been tested so that we figured out how they will register?
Yeah, but correlation does not equal causation. You can't think the consequent. Just because you see it here.
Absolutely, it does. If you figure out that the frequency of a color is a certain wavelength, and then you check to see what color something is, we can say something about the frequency. We've learned over time empirically that that's happened accurately enough that we can use that kind of stuff to reason. That's exactly the same thing here.
Scott, that's affirming the consequent fallacy. Just because
you're saying that you can't know anything.
Let you spiel. Let me spiel too.
I'm not spieling. I'm telling you that you're saying you can't know anything. Then
let the po.
Just because you've checked this gas in, like, you know, actually a lab, you checked it on Earth, and you verified that it has this wavelength of color, doesn't mean whenever you find that wavelength of color, it has that gas.
It doesn't guarantee that, but what it does is imply that it's probable. And especially if you do it quite a lot and discover that it's accurate over and over, then you can really start to have confidence in it. You can never ever guarantee it, and that would be affirming the consequence, guaranteeing it. You never do that. Hold on, stop your spiel for a second, let me finish. And if you think about it, the way knowledge works in general, of course what I'm saying is true, because there's nothing you could know if you had to avoid affirming the consequence the way you define it. But obviously, if you have a probabilistic belief, if you have confidence in something, it works out fine.
All right, I absolutely agree for your first part, which is we can say probabilistically that it's this on Earth, though. We've never once...
You can say it all kinds of ways.
We can induce it about, 22 miles up. We've never once confirmed it with samples or anything 22 miles up. So it's always going to be, probabilistically, it's like more and more confidence as we confirm on Earth. But we don't increase the confidence.
You know out some variances. You know how they use lasers. In this case, though, the case that we're actually talking about, that has happened. So in this case, you don't have any leg to stand on with the original claim of we can't do it.
Okay, show us the sample that we got 22 miles up.
No, you know how they use lasers to determine.
The research the web to you explain
it. Do you know how to use lasers in spectroscopy?
You're just wrong.
Take a guess on how they use lasers in spectroscopy.
No, just show the sample from 22 miles up.
They can find a distance by the time it takes for the light to reflect back from the sensor, and they can determine how far away those particles are.
That's not.
And then they can determine what their makeup is.
That's false.
Chemically, this is not news to anyone but you.
Well, provide the evidence then.
You provide the evidence, Kimo. You're the one that seems to care.
Not our claim.
Well, then don't worry about it. We're just telling you the truth. You can either learn the truth or you can not learn the truth. That's up to you.
Provide the evidence then.
Just search the definition.
I don't need to give you evidence. You want to know the truth. You're going to have to do some work. We're giving you the truth. You can accept it, or if you don't accept it, you need to go research.
Look at this. It comes full circle. I just searched the definition for ozone hole. The definition is a large area of the ozone layer over Antarctica that annually becomes depleted of ozone by the action of chlorofluorocarbons and other pollutants.
Yeah, CFCs.
Over Antarctica. Isn't that convenient?
What do you mean convenient? In what way is that?
Why is Antarctica the one, causing the ozone hole? Why would it be over Antarctica?
Isn't causing it. That's just where it
happens. But would it be over Antarctica?
Yes. Antarctica isn't causing the hole in the ozone layer.
But why would it be over Antarctica and not over some other place? If it's not caused by Antarctica.
What do you think it should be over?
Look, just stop being a fucking po for once in your life. I know
it says depleted of ozone by pollutants. Yes. Why would Antarctica have the hole if it has no pollutants compared to other places? You guys are speculating.
You're asking a question. I'm asking you a question. What do you think it should be?
CFC. Do you know how CFCs gobble up ozone? Have you understood or ever looked into how CFCs can gobble up ozone? What the ratio is?
Tell us why Antarctica has the hole, Zanuck, since you understand CFCs and pollutants so much.
Has to do with the atmosphere's flow.
Atmosphere's what?
Right. The atmosphere's flow.
Okay.
Why are you laughing like a moron?
I'm laughing at a moron.
Why do you? No, you're not.
You're a comedian, Zanuck. What are you talking about?
My understanding. Here's how it works.
Why do you think these are whole?
Here's how it works. The CFCs that cause the depletion, there's something about the Antarctic airspace that makes them more effective, and that's why the hole appears there. So they get mixed up because of airflow. They get mixed up everywhere. But if they're over the Antarctica, something about, I don't know exactly what the conditions are, the humidity and the temperature.
So you have no clue.
They're particularly effective in causing the hole to
that's a long way of saying you don't know.
No, I just read it. I'm literally just reading as I go. So I thought I would share with you
why. I can tell you why. Do a quick Google search, and you'll find that on the NASA website, they explain that persistent cold temperatures and strong circumpolar winds, otherwise known as the polar vortex, support the formation of a large and deep Antarctic ozone hole.
Interesting. I said exactly that.
Here's what I just read. As a result, ozone-depleted gases get mixed throughout the atmosphere, including Antarctica, regardless of where they were emitted from. The special meteorological conditions in Antarctica cause these gases to be more effective there in depleting ozone. So it has to do with getting there and then being more effective.
It's got nothing to do with Antarctica itself.
Ozone, which is
nothing to do with Antarctica itself.
In the world.
Conditions in that area.
Down to Antarctica.
You laughed at, and now
the wind pushes all the ozone in the world down to Antarctica. That's what you're saying.
Everywhere.
The ozone covers the entire planet.
Yeah.
Yeah, but the wind is pushing it down to Antarctica,
right? Like a moron. And they verified
the laughter of a knowing Poe. He's just trolling us.
Okay, well, look. If that's all you're going to say, farmers, just wait for other people, because we know that, and we don't need to keep saying that part. The answer to that thing that you just said, though, is it's not just in Antarctica. It's mixed up everywhere. It just happens to be in Antarctica. It's most effective.
They say that the hole is over Antarctica.
Yes, because it's most effectively creating the hole over Antarctica.
Okay, so it's thin everywhere. It's almost the hole everywhere. But
CFCs get spread everywhere. They're most effective in creating the hole in Antarctica.
Yeah, so basically the hole is only over Antarctica. I don't know why you keep on trying to rephrase it.
You said the wind is only going there. That's how it works.
The ozone.
It's only over Antarctica because of the conditions there make it easy for the CFCs to work. I just posted a link for you, by the way, if you care.
The CFCs that damage the ozone layer are not being produced in Antarctica.
Yes.
Correct.
You keep complaining about ozone by
magically pushes all the CFCs
to the wind. Percentage. They gobble up ozone. I think it was something like, I don't know, 5,000, 10,000 to 1. And it happens over the Antarctica, over the poles. This is where the holes are.
No, apparently not the pole.
Because of the atmosphere flow. As I mentioned, the very first statement, I mentioned that you laughed and giggled because you're an idiot.
Yeah.
Dude, you're so butthurt. It's not pole.
I'm laughing at you.
Specifically mentions Antarctica. It doesn't say the pole.
You're just a moron.
Pole at the north.
I told you the reason you didn't like it. You laughed at me, said I'm the moron, but you really are the moron. Projection.
Can you guys stop with your insulting one-ups? They're getting boring.
It's magically pushing all these chlorofluorocarbons and pollutants to Antarctica only.
I've already told you the answer to that. I've already explained the answer to that, dude. You're completely out of line for saying that. You've heard the answer 4 times %. Why are you purposefully, intentionally misunderstanding?
Here's a question. Why is the wind?
That's my question. Why are you intentionally misunderstanding? You've heard me give you the answer. Why are you ignoring it?
No, I'm asking the actual relevant question. Why is it pushing pollutants?
I told you the answer to something you just said. I told you 3 times, and you just repeated the wrong answer again.
It's being ignored because there's no demonstration to it. That's why it's being ignored.
Why am I doing what? What's your question?
I've told you the answer that it gets mixed up everywhere, and it's just most effective with the Antarctica about 3 or 4 times. And then just a second ago, you yet again asked, well, the wind's just pushing it down to Antarctica alone? Why do you keep doing
it? Is it more effective in Antarctica, Scott?
I don't know. It's something to do with the conditions of being around Antarctica, the humidity or the temperature. I don't know exactly what the conditions are that cause that to be true. As a conclusion, when I'm answering your question, but as a conclusionary statement, that's what the articles I found said, is that over Antarctica, it's more effective.
Okay, fantastic. So now, if Antarctica, if this stuff is being mixed everywhere,
yeah,
all right, and but somehow the winds, the polar winds or whatever, it's pushing it so that it's going into Antarctica. What else is being pushed into Antarctica?
It's being mixed everywhere, right? So that's everywhere, including Antarctica.
Yeah, but the chlorofluorocarbons, they said. So who was it? Farmer's Boy? Could you read out what you cited before, Farmer's Boy? You there, Farmers?
Here's what I read to you. As a result, ozone-depleting gases get mixed throughout the atmosphere, including Antarctica, regardless of where they were emitted from. The special meteorological conditions in Antarctica cause these gases to be more effective in depleting ozone there compared to anywhere else, which I think is pretty clear.
Not really, because it doesn't say what the meteorological conditions are.
Oh, it says in the article. I mean, I just haven't gotten there yet, but it says in this article if you want to know.
Okay,
that's just a detail.
Yeah, it's in the. I posted it for you.
The polar winds. If we could get that again.
For you to read percent.
Percentage. Maybe I can help out here. So, did you know that in Minnesota the air quality is really, really shitty? Like it's actually at a level that it's hazardous to health, right? There's a lot of smoke there in northern Minnesota right now. Did you know that?
Not that it was like actually hazardous to health, but continue.
Yeah, it is. It is. So, do you know where that smoke is originating from?
No.
Okay, in Southeast Oregon right now, there's a humongous fire. It's called the Bootleg Fire. It's this out of control wildfire. And that smoke is making its way over to the Northeast right now and over to Minnesota, especially Minnesota. So smoke that is being generated from, you know, a relatively restricted area in a state that's over 1,000 miles away is somehow making it to Minnesota, and it's making people cough up there.
Okay.
So that's your answer. I don't know why you are assuming that CFCs have to be made in Antarctica to make a hole in Antarctica. I
never once said that.
That is what you implied about 5 minutes ago.
You did say that. You said it over and over.
No,
yeah,
I said
you did.
These CFCs are somehow being pushed into Antarctica more than any other place. Number one.
No, that's not true. We just explained that to you, and that's what you keep saying over and over. That's not true.
So we have the same amount of CFCs and pollutants everywhere.
Yes,
right?
you've been told it like 15 times. I read you a quote that said the exact same thing. How is it that you're this completely slow? I don't understand.
So first question. If nothing's pushing the CFCs to Antarctica, how come do we even have...
Everywhere. They're being pushed everywhere, dude.
How come what percent? You can get to hear the finish of your last point.
Including Antarctica.
Okay, so then
you've been told that like 19 different times.
We're still square one. What's causing the ozone layer to be depleted?
I just posted you the answer to that. It's in the debate chat box. Read it.
Meteorologic conditions. If you actually have the answer, that'd be great.
I just posted you the evidence, and it says there it has to do with the temperatures and the way in which there's like an edge wind and something to do with the stratosphere, the way it is above the Antarctica.
Yeah,
there's a symmetry between the landmass and the ocean. But I posted the actual quotes for you to read if you want to learn the answer to that.
But you can't say them.
I just told you, look, in the southern hemisphere, the South Pole is part of a very large landmass that is surrounded by ocean. This symmetry is reflected in a condition that allows the formation of winter on a very cold region of the stratosphere on a very isolated and small part. The band of strong winds that circulate around the edge of the region, somehow, I don't know exactly, the low stratosphere leads to formation of clouds, and they're responsible for chemical changes that promote production of chemically active chlorines and bromines. These chlorines and bromines, this activation leads to rapid ozone loss. So it has something to do with the temperature of the stratosphere, the size in which the landmass is surrounded by the ocean, and some sort of circling edge wind.
Yeah, let me add to that. Let me add to that. Let me add to that real quick. Let me add to that.
Yes, this is how you do research. You learn a little bit, you learn more if you want more. You do learn a bit, you learn more if you want more. You continue to do that process until you're satisfied. If you're not satisfied at this point, you need to pick up the mantle and start researching yourself.
Clouds cause chemical changes, which cause the effect. That's basically what you said.
Something like that, yeah. A certain kind of cloud.
Go ahead, Zanik. To it.
It's a one-on-one of each of you and percent.
It's just dumb, dude. It's completely asinine of you.
It's a one-on-one then.
I mean, how long did it take you to even understand that it's not winds only pushing Antarctica?
You could say what temperatures come with some actual information.
I just did. You got lots of information.
It has to do with the sun's rays. God damn it. Has to do with the sun's rays as well. So adding what Veach said, there's another quote. I'll read it to you because you're obviously incapable of reading. The Antarctic ozone hole forms during the southern hemisphere's late winter as the returning sun's rays start ozone depleting reactions. Cold winter temperatures persisting into the spring enable the ozone depleting process, which is why the hole forms over Antarctica. These reactions involve chemically active forms of chlorine and bromine, as Veach said, derived from man-made compounds, CFCs. The chemistry that leads to their formation involves chemical reactions that occur on the surface of the cloud particles that form in cold stratospheric layers, leading ultimately to runaway reactions that destroy ozone molecules, the H3 we talked about.
All right, what's the chemical reaction?
In warmer temperatures, let me close one last sentence. Warmer temperatures, fewer polar stratospheric clouds form, and they don't persist as long, limiting the ozone depletion process. Do you understand now?
I understand perfectly. They mentioned ozone depleting reactions. They mentioned chemical reactions. What is the actual reaction? Do any of you know?
We don't know the answer to that, I think. And I think that at some point, though, if you don't know the answer to that, then maybe it's your turn to now teach us something, because we're learning this stuff on the fly, as you are. And so now maybe you could research that question and tell us the answer. It would be great to know.
No, but this is your guys' claim.
No, but we're giving you the answers that we have. You want more answers because you're, I guess, interested in the topic now that you're learning all this. That's great. Now, I would love to know that too. What is the exact, stop interrupting. What is the exact reaction? I'd love it. What do you think it is? Have you looked it up?
I'm not convinced there is one.
Well, why don't you try looking it up?
Well, that's shifting in the burden of proof fallacy.
It's not a burden of proof. It's do you want to learn about this or not? We've just given you a ton of information. Do you want to contribute to the? Why are you interrupting? Do you want to contribute to the information or do you not?
Like you can't have cold winter temperatures elsewhere?
This is not a conversation.
We just gave you a ton of information about why it's unique there. Do you want to add to this information or no?
There's nothing to add. You guys haven't put any information in there.
We have really tons of information. We told you about unique conditions. We told you about how the stuff mixes in the atmosphere.
Chemical reactions caused by clouds. And you haven't given any actual info.
Now you want to know something additional because you keep asking additional questions like, okay, well, let me ask you this, then let me ask you this. So you've asked a bunch and you've got a lot of answers. Now, do you want to contribute?
Good.
The problem
is you contributing to your model. What are you talking about?
A storybook like I do my kids, and they get it. I read it, and you're asking questions of things we've already answered. That's what's funny about this.
Well, he knows
how do the returning sun's rays start ozone depleting reactions?
Because again, let me read part of it again. Because the ozone hole forms during the southern hemisphere's late winter as the returning sun's rays start the ozone depleting reactions.
Thank you for repeating what I just asked. How do the sun's rays start?
Hold on. So we start having a change, a late winter. It's going on longer than anywhere else in the world. That's why. The winter's longer, but the sun's rays are now hitting. Because remember, the days are longer we're closer to the sun at that point in time as well. In the northern hemisphere and the southern hemisphere.
What? No, it's winter time for the southern hemisphere.
They have a longer winter. They have a longer winter.
You're not making
late
sense.
Winter, and so it's colder for later, and that's what gives a process of enablement to occur.
This is like I imagine a hamster running on a wheel right now.
No.
How
cold
do
winter temperatures
returning
persisting into spring? They're not cold anywhere else into spring. What part of that don't you get?
What do the
sun's temperatures persisting into the spring?
Relax,
doesn't happen.
Okay?
Doesn't happen anywhere else. Just in the southern percentage. Doesn't happen anywhere else. There's your answer. The cold temperatures that persist into the spring allow for this ozone depleting process.
Okay, here's a question.
Text. Right.
What do they mean by the sun's returning rays?
What do you think it means?
I'm asking you because this is your thing. I
understand words.
As the sun's returning rays. Returning from what?
What do you mean by the sun?
Returning from a trip to the store. That's what they're returning
What do you mean by the sun?
This is your link, man.
What are you talking about? You have to explain that question.
It's the sun's returning rays.
Which sun? What are you talking about? What sun? So every star is the sun, right? You're aware of this, right? When you figure it out, let us know.
I can give you the answer, but I don't think you'd understand it. It's really obvious to everyone but you. It's pretty simple to think about what that means when the sun returns. What do you think that means? If I said the sun's returning today, what does that mean? Morning?
Well, it means that your sun has got off.
It means that the sun is moving.
You're starting to see it, right?
Or if it was in college, it means he got back from college.
Bro.
Guess what? In wintertime, there's no sun down there for part of the year, right?
You're right.
Right.
The sun moves.
The sun's returning because it wasn't there before. Now it's there. And it stays cold even though the sun returning and the rays that start the ozone depleting reactions happen because
you're right. It went
and returning where it wasn't there before. Idiot.
Exactly. I think you're now flat earther. Good job.
No. How do you have no sun for 24 to 24 hours, and then another time of the year you have the sun?
You have a sun that's moving. It went and returned.
How do you have
on a heliocentric
night?
model?
How do you have night for 24 hours, and then another part of the year you have sun for 24 hours on a flat Earth? Please explain that for me.
How do you have a moving and returning sun?
No,
if it's stationary?
Explain the fucking question.
The question fallacy. Don't answer with the question. Give me the answer.
What was the question I asked first?
Because you're not listening.
No, idiot. You have to answer to one question at least. One question.
How do you have a sun that's apparent for 24 hours one time of the year and nowhere to be seen for another 24 hours at one point in the year? How does that happen on a flat Earth? Please explain.
Who says it happens on a globe?
It's happened all the question.
Again, asking the question fallacy.
That's not a fallacy.
Dude, it is.
Answer the question. You can't answer my question without giving me a question. Have you noticed that?
Your premise is faulty. Do you notice that?
Faulty.
No, it's not faulty.
It's a simple question. I could be a small child asking, Daddy, why does the sun shine for 24 hours at this time of year and it's dark for 24 hours?
Don't call me Daddy. That's weird.
What would you say to them? How does that happen on a flat Earth? Please explain. Use your imagination. Yeah,
dude. I'm not claiming that it happens on a flat Earth.
I didn't ask you to claim. I didn't say you did. I'm asking
you're assuming it.
And if the Earth is flat, how do you have the sun 24 hours and not have 24 hours?
What's the sun? What's the medium it's in?
A light in the sky that's moving, as you said, at
there's only
velocity.
one.
But then you said it changes velocity. Then you said it changes angle.
Come on.
Then you said it changes altitude. Dude, sit down.
We don't know what it is. We don't know what medium it is. Why would we
shut up?
Just assume a bunch of stuff.
Shut up! You're talking Jorbish things. Do you have something that is linked to reality? Something. You don't know what is the sun. You don't know what is the atmosphere. You don't know what is the earth. You don't know what do you know?
I know a lot.
What?
I know not to believe everything I'm told without evidence.
So this is not a knowledge, mate. This is a stupidity.
To not believe something for no evidence?
So have you ever gotten evidence of anything, percent?
Yes.
Yes. So
what do you believe?
What? So okay, what is your evidence of something that you believe?
There's a lot of evidence for a lot of things that I believe.
Exemplify. We're asking for example.
Dakotas is asking.
Yes,
right, so Dakotas, I have evidence right now that I'm using a device to communicate.
Well, fucking hell, that's not about the Earth. We are talking about Earth, not communication.
Only talking about the Earth. Okay. So I have evidence that the Earth is observably motionless.
That's your evidence.
That's my evidence.
So, how are you going to substantiate it?
Let's see.
With what you gonna? How are you gonna prove it to me? Because the Earth is not moving when the sun is moving around.
I don't need to prove it to you, because you, if you're being honest, prove it to yourself.
I'm extremely honest, and I see the sun moving over my head. How I gonna explain to myself? Because the Earth is stationary.
I said the Earth is observably stationary. You feel it to be stationary. Do you agree or disagree?
I don't know. I really don't know. Can
you know if you feel it?
Why I see? Shut up. Why I see the sun moving and I'm sitting?
Why do you see the sun moving and you're sitting? Because the sun is observably moving and you're observably sitting.
Okay.
We can't feel it.
This is your point of view. So if the sun is moving and I'm sitting, the conclusion is the Earth is sitting.
Occam's razor. It's empirical observation. Definitive evidence beyond reasonable doubt.
From where do you know? Because the sun is moving.
From where do we know that the sun is moving? We see it moving.
Yes, and not the Earth. No, so from where do you know that?
From our eyes, because we see it.
Okay, so how do I know? Because the sun is going over the horizon and is disappearing over the horizon, and I have that optical vision, because the sun is disappearing over the horizon and it's cutting the edge of the Earth. From where do I know? Because the Earth is not rotating.
What's your question?
So I see the sun going over the horizon. From where do I know the sun is stationary or the Earth is rotating.
Why would you get that idea when everything that you observe supports the other one?
No, it's not supporting.
Yeah, it is.
If
you
the
see
sun,
the sun moving.
If the sun,
you feel the Earth stationary. Why would you assume the exact opposite?
Because there are other things involved in here, but I'm talking about the sun right now, yeah? So
yeah,
if the sun is going over the horizon, if the sun is going over the horizon and is cutting the edge of the Earth, yeah?
It doesn't cut the edge. What are you
talking about?
Yes,
it's cutting. But if this is what I'm seeing, the sun is disappearing over the horizon.
Or into the horizon. Yeah, continue.
Entering in the horizon. How is it going to enter in the horizon?
The sun's disappearing, right? It's either going, depending on how you want to look at it, over the horizon or into the horizon, how you define horizon, right? Since the horizon is the observable, like, you know, the apparent intersection of the ground and the sky, it would be correct to say it's going into the horizon, since we know that there is a vanishing point. That's how our perspective works. But it doesn't really matter. I don't want to get bogged down into the details.
Okay, from where do you know it's a vanishing point?
The point is we see the sun moving, right?
So I don't know if it's a vanishing point, mate.
Hold up. The point is we see the sun moving. Our empirical evidence supports that the sun is moving. So
but
the
I
default.
See the sun. I see the sun.
Let me finish. I'm almost done.
I see half of the sun. 1 second. I see half of the sun. Yeah, disappearing. No, first of all, it's starting with disappearing from the bottom. Yeah, and slowly is disappearing to be at the end. And I cannot see the sun at all. But it's cutting in half. After that, it's cutting in the third part, and after that, it's cutting. Before it's gonna be disappearing at all. It's not disappearing like a small object in the distance. It's disappearing in percentages.
You don't know that.
How? This is what I am observing. Fucking hell! What do I know?
No, you observe that the sun is going into the horizon, and that the light is slowly going away. That's why we have sunset, and then we have dusk after. You know,
mate,
as it's going away.
It's observable because it's cutted.
Hold up.
The sun is
light,
cutted.
Hold up. Light attenuates, right? We don't know if the effect we see is caused by the sun moving farther away or the sun getting more and more obstructed. We can't map out every single ray of light to know how the refractions work.
I have a camera.
It doesn't
we have the same effect. You guys think it's the one cause. Hold up. It's not like I'm almost done. The point is we see the sun.
If you measure the size, it gets smaller. It doesn't get smaller. It doesn't get smaller. So if it's going away from you, it gets smaller.
It's cutted.
Maybe it does get smaller, but there's atmospheric lensing or magnification that's causing it to look the same.
No, it doesn't get smaller.
I have
you don't know
percentage.
That.
We measure it. It doesn't get smaller.
Yeah, but maybe our measurements aren't accurate enough to appreciate it, or maybe we can't. Maybe there's coincidentally it's offset by the atmospheric magnification. We don't know.
I have so fucking hell percentage. Can you shut up a second?
The point is, we see the sun moving. Because we see the sun moving, observably, it's supported by definitive empirical evidence beyond a reasonable doubt. The sun is observably moving. That is the default. Okay. If you want to say that the sun's not actually moving, and the Earth is moving, then the burden of proof is on you.
Because if it's moving, it gets smaller. You already said due to perspective. So if you're going to invoke perspective percentage, that means the sun has to get smaller. It's not.
It doesn't have to, because you're affirming the consequence. There could be other things at play.
We can measure it when it's above your head or setting. It's the same fucking size.
Exactly.
No, you're assuming that it's an object of mass and object of matter, and that the same rules that apply down here apply up there. When you don't even know what the medium is, you don't know what the object is. You're affirming the consequent, and it's a stupid assumption to make.
You invoked percentage. You invoked perspective. It's not getting smaller, so it's not going away from you.
It could be perspective, but maybe there's something else at play. You can't automatically assume stuff, Zanik.
Hold on. It's not going away due to diffraction or diffractive limit or anything of the sort.
You don't know that.
Because it's being blocked for something. Yes, because
you don't know that.
You said due to perspective, this object should behave a certain way optically.
If it was like all the objects on terra firma.
Percentage, what you can see is it doesn't get smaller. So you're invoking perspective, can tell yourself, yes, I'm not seeing this going away from me. I'm rotating myself, and it's being blocked by the horizon, by the
Again,
land.
Zanuck, you're assuming uniformity.
You are not assuming.
Listen,
He's not assuming.
you're assuming uniformity. You're assuming uniformity between Earth and the celestial things, the celestial objects. You're assuming uniformity between them. You don't know that. You've never been up there to confirm it. You don't know if it plays by the same set of rules. It might be a different set of natural laws. Who knows? Okay? Don't assume.
So what natural law can be?
We can't verify anything except
percentage.
Earth.
Tell me a natural law that can cut the sun in half.
You're not listening, bro. We don't know anything
I'm listening.
about...
I'm fucking listening for
half
an hour.
The nature of the celestial objects, the nature of the heavens. We don't know. We've never been up there.
I observed the sun cut it in half.
Works, don't you understand?
Shut up.
You don't know what the sun is. You don't know what the medium is. You don't know if there's magnification.
Can you shut up a second?
You shouldn't assume just because we have perspective that it's going to behave like every single object on Earth. Because it's not on Earth.
Can you shut up a second? A second.
Yeah, go ahead, Nicholas.
So I see the sun. I have a photo filter or a sun filter on my camera. Fucking hell. I can see the sun. What's my point? I photographed the sun for thousands of times. From above my head and going straight to the horizon. The sun is cut in half exactly when the sky is meeting the horizon. Yeah. So
okay, what's your point?
Who is cutting the sun in half and is not disappearing is not making to be very very small in distance to do into the perspective. Camera obstruction.
Apparent. It's not an actual. It's apparent, just like the apparent horizon.
Explain to me what's apparent in observation of seeing the sun cut it in half.
No, it's not actually cut in half. It's an apparent obstruction.
It's not. It's 100% cut by the Earth.
You don't know that.
Can you explain to me why?
You don't know that. You know why?
How do I know that?
I'll tell you. Because you're looking at the Earth, right? All you know is that there's these lights reflecting off of that surface, entering your eye.
What light? I have a
light.
Photo. I have
reflecting off of the ground.
I have a sun filter on my camera.
I understand. Listen. So you have half the sun being obstructed by the ground, right? The sun is cut in half. All you know is that the light that's entering your eye from that ground that's obstructing the sun, or that water, or what have you, all you know is that it's entering your eye. You don't know if it's, curving or what have you. It could be, the light could be bending and entering your eye at an angle, and so it seems like it's straight ahead, but it's actually not. You have no idea.
The light doesn't cut the object. Do you understand those things, or it's very complicated for you to understand it?
You know how eyesight works, right?
Idiot, the light doesn't cut objects.
No one claimed it did. We said the light is entering your eye. The light from the ground. It's reflection.
It is the sun? How it is? What reflection, man?
The reflection of the light off the ground or water, which apparently is obstructing the sun, is entering your eye, maybe at an angle. You have no idea.
And the effect is not cutting objects in half.
No, the effect would appear like that.
No, it's not at all like that.
All right, someone else can take over.
No. You don't understand what's happened.
I don't think you do.
This is the biggest problem. No, I understand it extremely well.
You don't understand that refraction.
Because I have been observing those things. I have been observing those things for 1,000 of times. You don't understand what's happened with the sun and the atmosphere.
With all due respect, you're having trouble understanding.
What's the index of reflection that you can do observations?
Is it possible? Here's a question.
1 second. It's not possible, my friend. It's not possible for an object on the faraway distance to be cut in half by an obstruction.
Is it possible?
By a reflection. Only by an obstruction.
Is it possible that you're looking out at the horizon and the light that is reflecting off of, the ground is entering your eye at an angle, that it's bent? Is that possible?
Mate, you talk about reflection. Doesn't matter. Reflection or deflection doesn't matter in this equation.
It very much matters.
Not even at all. I'm talking about open window of observation. When the index of reflection is reduced to minimum.
It doesn't matter though, because we're talking
why the moon in some parts of the Earth, you see it over exactly like the sun. You see it cut it in half and during the night, the index of refraction is extremely low. Why? Who's making those objects to be seen at cut it in half?
You still will see that the ground is obstructing the thing. It appears like that, right? And because it appears like that, it's possible that you don't know that it actually is. No, because the horizon is an apparent thing. So you don't know if that light is actually bending or going straight. You have no idea.
I have 100% idea about the index of refraction during the night. So you don't understand what's happened. This is the biggest problem. So the obstruction that is put in place, the obstruction that is 1.1. The obstruction that is put in place on there is exactly the Earth.
And it's probably less than 1.1. Let's be real.
No, it's 1.1. Believe me, it's 1.1. It's an average point.
It's probably less than 1.1.
No, it's not one. You calculated on 1.1.
Era STP is 1.000237. So it's probably going to be a little bit higher than that if you're talking over water.
Put it on 1.1 and you're going to have a correct equation on everything. You don't have to go to lower. You don't have. It's an average point. You don't have to go with the lower amount. Put something there and you're going to have the correct result. Okay, so if you're gonna do an observation during the night on the moon that is cut in half, is not even a fucking reflection that is gonna take in place. It's gonna be exactly the age of the Earth, and you're gonna see the moon disappearing in the distance. So the moon is going over the Earth. Simple as that, like the sun. So we are rotating. It's easy.
You haven't showed that.
You haven't showed that. So you need a 24 hours video right now.
No, what we need is definitive evidence. It doesn't need to be 24 hours.
It is the definitive evidence. Fucking hell, take a look or go on the seaside and take a look on the moon.
Yeah, you go to the seaside, you take a look at the moon. The moon is moving, right? Where's your definitive evidence moving, that it's not?
Okay. Take the sun in this case. Take the sun in this case in the open window observation. When the index of refraction is going to be closer to 1.1.
Okay.
And it's going to be there, exactly cut it in half like all the time.
Okay. What's your point?
Oh, the Earth is rotating.
That's an affirmative consequent fallacy.
No, consequence fallacy.
You don't know what the sun. Listen, hold up. You know what the sun is.
Seeing something that is not shrinking in size is not a logical fallacy. Is for not even any consequences. Did the sun is shrinking in size in the distance? Did the sun with a photo filter? Did the sun is shrinking in distance? Mate, I have asked you. My sun does shrink in the distance when I'm taking the picture over the horizon. What the fuck is... What's happened? Am I still on the server?
He just muted himself.
Oh, okay.
What happened? Oh yes.
Let me explain to you what happened. Another one, the bite to dust.
No, he didn't bite the dust. It's
oh yes.
The problem is,
doesn't understand
what
perspective. He doesn't understand perspective. He doesn't understand the Earth rotation. He doesn't understand nothing. So it's exactly in the same situation like you. A dumbass who's living in the Earth, consuming the oxygen for nothing. Have fun.
Cringe. Cringe.
Who's that? Who said that? Is that Mel?
Mel. And they pop out with little holes in the ground, don't they? Because they're fucking...
Problem is, Decodus, why these things break down, and because I've got the patience of a saint, see, with you guys. Now, most flat earthers have a very short fuse.
Patience of a saint, my ass.
Now, I'm talking.
Yeah, right.
Yeah, so I've got the patience of a saint here, Decodus, right? And a lot of flat earthers have got that short fuse. And it's like, if you just start talking, you know, rhetoric.
Too much shit. Yeah, too much shit.
There you go. Mel explicitly explained it for. Then it's like.
Mel, keep us talking. Shut up.
Brian, your mic is low.
My mic's low.
Oh, it's better now.
Yeah. Brian.
Greg, be quiet. Chemo's talking.
I have not got a short fuse.
Oh, right.
Everyone, be quiet. Chemo's talking.
No,
I haven't got a fuse at all.
Fucking hell. So why is it like, why are you suddenly targeting me then, Chemo, you bugger? Chemo, go and get a cup of tea.
Sorry about that, Dakota. My internet died.
Don't worry about it. Shit happens.
Yes, it does. What kind of tea are you drinking, Tao?
Coffee. I had a tea drinker, mate. Sorry. Love me coffee. I really like tea. I drink tea if it's like hot and I'm out working because it cools you down, but coffee, I drink it all the time, 24/7, yeah.
There's more variety with tea.
Well, there are, yeah, but tea's fucking expensive. It's not cheap. Not for the decent stuff, anyway. Father a fucking box. You know, you only get 40 bags in a box. What's all that about? Go down to your local supermarket, you get 40 bags in a box for like 40p. You know?
That's why you gotta stock up when you're traveling.
Yeah.
You have to get 40 bags in a box.
I mean, I like all that, like Darjeeling and all that shit, you know, but it's expensive. I'm a purist as well, you know.
The Asian chai.
Twinings, right?
Twinings, yeah, I used to get them delivered, yeah, with a little black van with a gold writing on the side, yeah. Used to come and I like them rose teas and all that, you know, all those different like aromatic teas that are really good for you. I like them ones.
Yeah.
Them, you know,
I'm a fan of cinnamon tea.
Flavored teas, you know. Aromatics, them sort of teas. Good for you. Wait,
you tell me.
To be honest, I think you could probably make your own tea, like your own aromatic ones. Just take some like black tea and then add in different herbs and spices and stuff.
Thing is that you can't do it all day because it changes the, what they call it, the acid in your stomach. And then when you want to come to eat, you don't want to eat because your stomach's all fucked up. You know, you got to be careful how much you drink of that stuff.
That's true.
Well, anything really. If you take anything into excess, then it is a bit bad for you, isn't it? It gives you gut rot. Yeah, I've got stomach aches. You shouldn't have eaten it or drank it then, should you? You know, you do get told these things, but we still do it. You know, that's the rebellious side of us. You know, we're going to do it anyway and find out for ourselves. Yeah, all right, yeah. Learn the fucking hard way like you all do.
How do you drink your coffee?
Usually cold after about an hour of having it.
With coffee and cream.
Oh, coffee.
You know what I mean?
Sugars. Yeah, milk, 2 sugars, NATO style. Yeah.
What is it? I like my sugar with coffee and cream.
Yeah, 3 sugars is too much. It goes too sweet then.
For like a mug, a regular sized mug, I could probably do 4 or 5 sugars. 5 sugars.
No, 2 sugars in a pint mug. That's enough still. All you're doing is spreading it out in a lot more water.
A pint? Oh, I would have 7 sugars.
No, you don't need that. You see, you've got to understand surface area over volume ratio. And the amount of sugar you're putting into that little fucking volume of ratio, you know, it's like, you know.
You got to understand differences in bitter and sweet, you know, acclimation.
Yeah, it dissolves into it okay, but it's very concentrated. Whereas if you had like a 2-pound mug of coffee and you put 3 sugars into it, it just tastes like you'd put 2 in it because the volume ratio's changed. See? You can dissolve more parts per million into the liquid that you've got.
No, but it would still be super bitter for me, man.
Well, yeah, it would be for you because you're probably a sweet tooth. You know, one of them sweet eggs.
Yeah, exactly.
Yeah, no. Honey's not enough for you, is it? I see.
Yeah, it's way too bitter, man. It's disgusting.
All right. Yeah. Let's see.
I'd rather get diabetes than drink bitter coffee all the time.
Yeah. It depends what you're used to. I mean, you've probably got some really decent coffee out there that you can, you know, like boil in a fucking kettle on a fire somewhere. You know, that's decent coffee. But they don't make that anymore. Yeah, it's hard to do, isn't it? I don't really fancy making a fire in my fucking kitchen, you know. But plus, I could boil some on the pot in a pan, but it's not the same, is it, as an open fire and that? It doesn't taste the same. You know, it's weird.
Yeah.
Boiled coffee on an open fire is like 10 times better than any fucking coffee machine can make it.
Anything on an open fire tastes better.
Oh, it does, yeah. It's properly cooked as well, isn't it? Yeah. Cooked right through with them bloody ovens and that, do it. You got to leave them until they're cremated until it's cooked properly nowadays in an oven. That's not fun at all, is it, eating carbon?
Yeah, but I don't know if it's necessarily, like, some people say it's carcinogenic when you're eating something like burnt.
Well, we are carbon.
I don't know if it actually is, though.
We are carbon cells. We're made up of carbon. So eating